Morning all, and welcome back to the WTF, and meet Gator, who is my chief treasurer, does all the accounts, and got something inside the shack to show you guys today. It's a bit of a cold morning here. There's the old aerial. Right, let's go inside. Almost crashed into the digger. Got something interesting to show you as usual. Right, take a look at this, what I've been fiddling with. I've got another one over here actually. Where is it? Look at that. Get out the right way. Hope you can see that. That is a aircraft TGT gauge. And we're going to have a look at that in a minute in closer detail. And if you don't know what TGT gauge is, turbine gas temperature. So basically it measures the exhaust gas coming out of a jet engine, and I bought a couple of these, a few of these off eBay, and I thought I would well, a couple of them are working, but one of them isn't. So the one that isn't working so well I've decided to open up and we can have a look inside. So give me a minute to set everything up and we'll have a look. Right, so this instrument, as you can see, it's a, as I mentioned before, TGT gauge, or exhaust gas temperature gauge, and this one would have come from a Tornado jet GR4, GR7, whatever it is, GR4 I think. Anyway, so this would be inside the cockpit of the Tornado, and as I mentioned, measures the exhaust gas temperature, which is very important when you're starting a jet engine, because you need to make sure you know what the temperature is, otherwise it might overheat. So this is actually quite a complicated unit, and it's quite well built, and for what it is, I would say it's fairly well over engineered. This type of unit is actually called a synchro type gauge. And as I'll show you in a minute, when I've got prepared earlier, as they say in Blue Peter, it's full of electronics and it's really well engineered actually. And the way these things are set up are that they're rigged up to the thermocouples on the exhaust, and they basically measure the voltage of the thermocouple. I mean, this has got lots of fancy electronics in it. You've got a needle pointer here, and there's a gate which also gives you a digital reading of the temperature. If you look on the other side, got a big multi-pin connector there, which is actually quite interesting because only a couple of those, or only a few of those pins are actually used for it to make it work. And this one here is a slightly different type. This is probably a more simpler one. This is, I think, came out of a Nimrod. But as you can see here, this one's got two connectors there at the back, which you would use. Try and bring it a bit closer. Where you would connect your thermocouple. And usually with these, they usually require a series resistance. Most of the virtually all thermocouples on jet engines are K-type thermocouples, so they'll measure up to 1000 degrees, which is what we've got. What we got there. 0 to 10 times 100. These actually I prefer because they're a lot simpler. So when you're making control panels for engines, you can use one of these. It's a lot easier to set up. But I got these from I got this one from eBay, and it's dead cheap. It was going for sort of 11 quid each, so I thought I'd buy a few. One of them, well, two of them sort of work. They're a bit noisy, but yeah, this one does seem to be alright. it's a bit noisy, it does seem to work. And I'll show you a way how we can check these are working without having to fire up a jet engine and connect it. Just have a look at that one. So you can test these quite easily. I've got a thing set up here on the bench where we can test them just using a couple of resistors. So I'll show you that now. So, as I mentioned, this is one that I've prepared earlier. Just get it into the picture. And I've taken the back off. There's a few screws at the back there which unplug. And first thing you'll notice, there's a toroidal transformer. So I think the way this thing works, it's 28 volts in. And when this thing is fired up, and you'll hear it in a minute, it makes a 400, well, what sounds to me like a 400 hertz buzzing noise. So I think this thing probably works on all the electronics, or this transformer probably has a 115 volt transformer or something in it. I'll just see if you can bring it a little bit closer. Well, you can see that it's really neatly done actually. And then underneath there's a motor there which obviously controls the gauges, the gears and everything. You can see that there. So those are the digital readout. And then it's all sort of screened off with this. I'm not going to open it because this one does actually work. It didn't work to start off with, but I gave it a spray of silicon spray there, and it over the gears. I don't know if you can see that. I'll try and bring it into the centre of the picture. You've got a little gearbox there controlling everything. I mean, this is really a piece of fine electromechanical engineering. And if you look on the box, it's actually these instruments are actually made by Smiths, which I don't think exist anymore, but they used to be in Cheltenham, and it actually says so on the box, on the aluminium case. And you've got a little PCB there. Lots of little wires. Anyway, let's see if we can fire it up, and you can have a look, see if it works. Well, it should do. This one sort of works. Yes, as I said, it initially didn't, but we'll fire it up and see what happens. Right, I've rigged this up, and I've sort of set it up so you can see it quite nicely. And so we've got 24 volts, which is the supply voltage for this this instrument. And I've got a couple of resistors set up so that basically as a potential divider, so that we get about a few millivolts, which will simulate the thermocouple. Now, just as a rule of thumb, 24 millivolts, 25 millivolts usually corresponds to about 600 degrees on a K-type thermocouple. So if we crank up the voltage, we'll see hopefully that the needle and everything works. So, okay, so got 24 volts applied, and first thing you notice is that that red warning gate lifts up, and you can hear the noise it makes. It does sound like 400 hertz, I must admit. So I think it's all got a little built-in power supply. It's really quite clever. So it's reading 26 degrees, which I think is about as low as it goes, which sort of corresponds to room temperature. So I'll increase it up a bit. So you can imagine the pilot starting a jet engine on this Tornado, and it slowly goes up. Now this one was playing up a little bit, this instrument, because when I used to get past about 800 or so, the needle would stick. Yeah, it seems to be behaving itself at the moment. So it goes up to 1,000. There we go, 999, I guess. So I'll whack it all the way down. Now if I switch the thermocouple off, it should go to naught. So I'm going to I'll switch the power supply off for the which is imitating the thermocouple. There we go. And if I switch the power supply off, that gate should come back into position. There we go. So that one more or less works. And I was lucky, I got about 3 of these, so I mean you can imagine one of these would cost well, I hate to think when it was brand new, so probably I would have guessed something like 10 grand. Probably, yeah, probably maybe a little bit less, I don't know, but quite a lot of money. So I picked this up for a tenner off eBay, so did quite well, I think. And the 3 of them I got all seem to work and check out more or less okay. So so it might be good for a control box for for an engine, I suppose. So there we go. Anyway, that's it. Those are TGT gauges, and hope you enjoyed the video.